Hey everyone, it's Mr. N here, and today we're going to be talking about the geometric means for this video. And if we have a right triangle, such as this one that is shown, and we drop an altitude down, there's three things that can be the geometric mean. Now remember, we talked about what a geometric mean is in class, so now we're just going to go over the process of finding them. So this leg can be a geometric mean, this leg can be a geometric mean, or this altitude here. So again, the altitude can be a geometric mean, this leg can be a geometric mean, and this leg can be a geometric mean. But we will not use this. This will not be a geometric mean, only these three items. So let's label these. Let's label this one X, let's label this one Y, and let's label this one Z. So we went over the formulas in class and we said if this altitude, this X, is the geometric mean, it's the geometric mean between these two parts, A and B. A and B. So that's for the first geometric mean. If we have one of the legs, let's call Y as our geometric mean, we'll put the geometric means on the corners like that. Well, then it's the geometric mean of the part that's adjacent to it, this A, and the whole hypotenuse. So it'll be this part and the whole thing. So in other words, it'll be A and then A plus B. And then we've got our third option. If Z is the geometric mean, let's rewrite that. If Z is the geometric mean, it's the geometric mean, again, if that's the geometric mean, is a geometric mean of the piece next to it. So the piece next to it, and then the whole hypotenuse there. Next to it, whole thing. So that would be B, and then the B plus A. So that whole part. So these are the three things that can be the geometric means, and that's what we're going to work with on this worksheet. So let's look at number one. We are to find any of the missing variables. So let's start with something basic. This is our X right there. Well, we know that this is the altitude, and since I have a right triangle, and then this is the altitude of that right triangle, it is the geometric mean of those two parts. So X is the geometric mean of 10 and 5. So X squared equals 50. So X will be the square root of that. So X will be, if we reduce this down, this is 25 times 2, will be 5 root 2. All right, let's move on to the next one. Again, we can start with X, we can start with Y, or we could start with Z. It doesn't matter. Let's go ahead and start with Y. If Y is the geometric mean, it is the geometric mean of these two parts. So 24 and 6. So we end up with Y squared being 24 times the 6, which gives us 144. So Y will be 12. All right, what if X was the geometric mean? If X was the geometric mean, right here, it's the geometric mean of this part of the hypotenuse and the whole thing. So 6, and then it would be 24 plus 6, which is 30. So again, let's indicate, I'm going to write it here as 24 plus 6 for right now, so you understand that it's the whole thing. So this becomes 6 over X equals X over the 30. So X squared will be the 30 times the 6, which was 180. And we could break the 180 down into, let's see, 9, if we say 9 and 20, and then 4 and 5. So 180, let's say 180 breaks down into 36 times 5. How about that? And we could take the square root of that. So X is the square root of 180, which ends up being 6 root 5. Okay, let's find Z. Well, for Z, if that is the geometric mean, it's the geometric mean of the piece next to it right here. Notice I'm not using the leg, I'm not using the X, I'm using the hypotenuse part, 24, and the whole thing. So 24 and the whole thing, which is 24 plus the 6. So now I end up with Z squared as being the 24 times this 30. So 24 times 30 comes out to be 720. So z squared is 720. And then we could break that down into, let's see. I know that's 144 goes into it. Oops. 144. So 720, if I break this down into 144, it'll be times 5, and I could take the square root of that. So z equals the square root of 720, which broken down will be 144 times 5. So z is going to be 12 root 5. All right, let's move on to number 3. For number 3, again, here's our situation. There's our variables. Let's take a look. Again, it does not matter where you start. If we start with the y, the x, or the z, let's start with the x this time. Let's do something that we haven't done. So we'll start with this x. Oops. X is the geometric mean of this part next to it, not the other leg, not the other leg. So it'll be the 25 and the whole thing, 25 plus the 20, which will give me 45. So x squared equals the 25 times the 45, which is 1125, so 1,125. So x will be the square root of 1125. Now let's practice breaking this down. This is going to break down to, let's say, 25 times the 45, and this will be 9 times 5. So the square root of here is 5, the square root of here is 3, so 5 times 3. So x will be 5 and 3, and then I'll have left the square root of 5. So x is going to be 15 root 5 when I break this down. All right, let's do the next one. Let's just move on to y. If y is the geometric mean, it's the geometric mean of these two parts, 20 and 25. So y squared is 20 times the 25, which is 500. So y is going to be the square root of 500, and that's 100 times 5, so I could take the square root of that, so y is 10 root 5. Okay, let's do the z. So for the z, we end up with, if z is my geometric mean, it's the geometric mean of the piece next to it, 20, and this whole hypotenuse piece, which is 45. So z squared will be 20 times the 45, which comes out to be 1,400. And breaking this down, we end up with z equaling the square root of 1,400. 1,400 is 100 times 14. So this 14 doesn't break down. The square root of 100 is 10. So z is 10 root 14. All right, moving on to number 4. Let's see what we could set up here. With number 4, if I set this up using, let's say, the x first, let's go with that since we'll just go in order, x, y, and z. This is the geometric mean. Again, we're not going to use the leg, we're not going to use the y, we're going to use the piece next to it. And the whole thing, which will be 4 plus the 32, which is 36. So x squared is going to be 36 times the 4, which gives me 144. So x will be 12. Take the square root of that, we get 12. Y, if that's our geometric mean, again, it's the part of the hypotenuse next to it, 32, and the whole thing, the whole hypotenuse, which was 36. So we end up with the y squared equaling the 36 times the 32, which comes out to be 1152. So y is the square root of 1152, which we can say is 36 times 32, right? If we just do that route, 36 times 32, right? Because I know the square root of 36 is 6, and 32 can be broken down into 16 times, we'll say 16 times 2. So we could take that square root as well. So y will be the square root of 36, which is 6, square root of 16, which is 4, and then I have left over that root 2. So y is 24 root 2. It's good to practice the simplifying of the square roots on these problems. So that's why I'm doing it this way instead of getting decimal answers. So let's just continue that route. Okay, and let's do z now. So if z is our geometric mean, it's the geometric mean of these two parts, 4 and 32. So z squared equals 32 times the 4, which gives me 128. And let's see, 16 goes into that 8 times, so z will be the square root of 128. We can say 16 times 8, and this is 4 times 2. So the square root of 16 is 4, the square root of 4 is 2. So z equals 4 times 2, and then I have left over that square root 2 right there. So z is 8 root 2. Again, it doesn't matter how you break these down, but it is good practice, instead of just using our calculators to take the square root. Okay, we've got 2 more questions. So that was 1, 2, 3, 4, and let's do question number 5 and question number 6. So it's the same process on these. We'll start with x. If x is the geometric mean, it's the geometric mean of the piece next to it, of the hypotenuse, not the other leg, which is 4, and the whole thing, 10. So x squared equals 40. X will be the square root of 40, which is 4 times 10. Square root of 4 is 2. So x equals 2 root 10. Okay, next we've got y. So if y is our geometric mean, again, it doesn't matter. You could have solved for z first, and then did x, then y. It doesn't really matter. So if y is our geometric mean, it's the geometric mean of the part next to it and the whole thing, which is 10. So y squared is 60. Y is going to be the square root of 60. And the square root of 60, we could break this down to be, let's say, 4 times 15. And the square root of 4 is 2, and I'm just left over with the square root of 15 because I cannot take that. I cannot reduce that any further. Okay, and our last one here. Let's go for z. If z is our geometric mean, it's the geometric mean of these 2 parts, 4 and 6. So z squared is 24. Z is going to be the square root of 24, which is 4 times 6. And the square root of 4 is 2, so z is 2 root 6. Okay, let's look at this last one. If x is our geometric mean, we can't. Look at where x is now. We've got a problem here. X is not a geometric mean. X is part of this hypotenuse. The only things that are geometric mean are the y, the z, and the 12. So let's use this 12 to help get the x, because if I know that 12 is the geometric mean right here, it's the geometric mean of these 2 parts, x and 16. Suppose I would have used the y. If I would have used the y, then I would have to say x and then x plus 16. So if I was given a number there instead, which I'll do an example of real fast for you after this. I'll put one up where we do have a number as one of the legs, because I see that in all these examples we didn't have a number as one of the legs. So I'll do that. So in any case, I did 12 as being our geometric mean of x and 16. So x times 16, I'm going to cross multiply, equals 144. So at this point, I could say 144 divided by the 16 will give me 9 as my answer. So the x is 9. So now we're going to use that in the other part. So if I say y is my geometric mean, it's the geometric mean of that, which I just found to be 9, and the whole thing, which is 9 plus 16, which is 25. So y squared equals 25 times the 9, which is 225, and y will be 15. Okay, and let's do our final part to this. Let's do the z. If z is our geometric mean, it's the geometric mean of 16, and the whole thing, 16 plus 9 is 25. So z squared equals 16 times the 25, which gives me 400. So this is going to be, z is going to be the square root of 400, which is 20. All right, so now let's do the one I was talking about. Okay, suppose we had, let's pull this up a little bit. Suppose we had this triangle, and I gave you, here's my right triangle, there's my altitude, and I gave you this piece as being 10. Let's say this piece is x and this piece is 15, and I asked you to solve for x. So notice now this time one of the legs right here, this leg is our geometric mean. So if we use that leg 10 as being the geometric mean, it's the geometric mean of the piece next to it, x, and then the whole thing 15. So you would set it up like that. So in this case we'd have 15x equals 100, so x will be 100 divided by the 15, and 100 divided by 15 comes out to be 6 2/3. Okay, you could set it up like that. Now we can make this problem even way more difficult by just saying hypothetically, and I'm just going to say, suppose I didn't give you this 15, suppose I told you that was x and say this was 6. Well, then you'd have to set it up same way, like this, and then say this piece is x and this piece is x plus 6, and then cross multiply. This is a tough one to think of right here off the top of my head, because you'd have to make it so that it factors and works out, because here you'll end up with x times x plus 6 equaling the 100, so x squared plus 6x equals 100. This one doesn't factor so nice, so you would have to come up with a problem with numbers here that work out. So, but you get the idea. Anyway, hopefully this review helped. Good luck on the geometric means, and I'll see you next time.